Are you able to hear me?
Yes, sir.
Okay.
Good evening, sir.
Yeah, good evening. Start பண்றோம்டா. நீ யோசிச்சுட்டு இருக்க டீப் தாட்ஸ். என்ன வேணும்? பேட்ரியாட்டிக்கா? We'll get started. எனக்கு ஒரு புக் மட்டும் தாயா. See, listen to this. Guys, listen. Listen, this is a slightly, I'll not say complicated, slightly a lengthy concept that we are going to discuss now. No. எப்படி கோரஸ்ல சிரிக்கிறாங்களா சண்டை போடுறாங்களா? I'll go and see. Right. என்னடா என்ன நடக்குது? போயிட்டான். Okay, we'll get started. So I told you some important concepts yesterday, right? Give me a sound. So next method, so we understood how to solve problem based on completing the square, right? So next set we'll see for the next set we'll see how to deal with problems which involve this kind of a format. See, px plus q divided by ax square plus bx plus c times dx. How to integrate this? Or if you have px plus q divided by root of ax square plus bx plus c times dx. Okay. So basically, when you look at a problem, this method should come to your mind. That is, when there is a problem which has a linear equation, linear polynomial in the numerator and a quadratic polynomial in the denominator. So the quadratic polynomial can either be without a square root or with a square root. So whenever you have this thing, what you will do is the first step is you will write the linear polynomial px plus q is equal to a is some number, right? Some constant a times d by dx of the quadratic polynomial ax square plus bx plus c plus capital D. So this is the first step, right? So there is a reason why you're doing it like this. Okay. So once you do it in this way, then you will be finding out the value of a and b and then substituting it, but don't simplify it again. So through this process, you will equate, find out the value of a and b, and then you will substitute it back. The reason why we are doing it like this is because you have this px plus q divided by ax square plus bx plus c, right? So then what will happen to it? It will be a into d by dx of ax square plus bx plus c, the whole divided by ax square plus bx plus c, plus b divided by ax square plus bx plus c. So logically speaking, what will happen is, if this is taken as t, this will become dt. So that you will directly have the formula of log of something. And for this one, when you have a constant in the numerator and a quadratic equation in the denominator, the quadratic expression is actually solved using completing the square method, and you will apply one of those 6 formulae. Actually, not one of the 6, one of the first 3 formulae. That is dx divided by x square minus a square, or dx divided by a square minus x square, or dx divided by x square plus a square. Is that clear? So that is what you will do when there is no square root for the denominator. Whereas when you have a square root, in this case, what you will do is you will use any of the 3 remaining formulae, that is the 4th, 5th, or 6th formula to solve it. Okay. So this is only theoretical approach. I'll show you with a problem itself. So the important takeaway from this problem is, from this concept is, you should write the numerator. Listen to this carefully. This is the most important step. Whenever you have a linear polynomial in the numerator and a quadratic polynomial in the denominator, linear polynomial is equal to a times d by dx of quadratic polynomial plus b. You should remember this. You should remember this. Is the point clear? So make a note of it. So don't worry, don't think too much. Just copy that. I will teach you with an example, you will understand. Square other. Those who are online, could you understand?
Yes, sir.
Okay. So shall we see an example? Listen. Listen to this. So let's solve this problem. It says find the integral of x plus 2 divided by 2x square plus 6x plus 5 times dx. So it is of the form linear by quadratic. So what you will do is you will write linear is equal to a into d by dx of quadratic, that is 2x square plus 6x plus 5 plus b. So that's what you write. No? Px plus q is equal to a into d by dx of ax square plus bx plus c plus b. Right. So this will be equal to a into, what is the derivative of this? 4x plus 6, and you have a plus b. So collect all the x terms. So you have 4a times x plus 6a plus b is equal to x plus 2. So compare the x terms on both the sides. 4a is equal to 1. I hope you understood it is 1x. It's not 1.x. Okay, it is 1x. So 4a is equal to 1. Similarly, 6a plus b is equal to 2. So a you got it as 1 by 4. So a is equal to 1 by 4. So substitute it here. 6 by 4 means it will be 3 by 2 plus b is equal to 2, which implies b is equal to half. Cos 2 minus 1.5 is half. Am I clear with this? So what is the meaning of this is, you actually convert this question into this format. In the sense, in the place of x plus 2, I can write a into this thing. Okay, to put it simple, a into 4x plus 6 plus b. Okay, all that you need to do is take this a and b and substitute it here. So it is going to be 1 by 4 into 4x plus 6. Don't simplify it, okay? Plus, what is the value of b? Half the whole divided by 2x square plus 6x plus 5 dx. Did you understand? So this question and this step are the same. Because when you solve this, you will still get back x plus 2 only. If you want, you can do and see. Just because of the first problem, you can try and see. So when I multiply with 1 by 4, what am I going to get? X plus 3 by 2 plus half. 3 by 2 plus half is 2. You will get back x plus 2. So that x plus 2 is what you have broken it into this kind of a format. There is a reason for it. Okay. Now what you're going to do is spread each term with the denominator. So I'll take the 1 by 4 outside. 1 by 4 into integral of 4x plus 6 the whole divided by 2x square plus 6x plus 5 times dx plus half into integral of 1 by 2x square plus 6x plus 5 times dx. So same thing, same denominator. So now what will happen is, if I take this as t, what will this become? dt, no? So 2x square plus 6x plus 5, if I take it as t, 4x plus 6 times dx will be dt. So can I directly do that? So 1 by 4 into, I'll get log of, I'm skipping that step. I hope everyone is clear. I repeat it. You take this as t, this will become dt. So what is dt by t? Log t. But what is t? The denominator itself. So log of 2x square plus 6x plus 5 plus half, I will leave it as it is. For the second part, you need to do the completing the square method. Okay. So I'll write it here. Plus half into. So what should I do for completing the square? What should I take out? First, make sure that the coefficient of x square is 1. So coefficient of x square is 1 means take the 2 outside. So half is already there into, I will take the 2 outside into integral of, what am I going to get? Dx divided by x square plus 3x plus 5 by 2. Okay. See, let me call this one as I1. So basically I1 means first integral. Okay. This is the result of the first term or the first expression, right? So I'll call this as I1. Now I'll call this as I2. I2 alone, I'll solve it separately, right? So what am I going to get? 1 by 4 into integral of dx divided by x square plus 3x plus 5 by 2 means it is x plus 3 by 2 the whole square. So I hope you all remember that. First put x, the middle term has positive sign, put a plus. So half of the coefficient of middle term 3 by 2 the whole square plus you have 5 by 2 already and you need to subtract back the square of this, that is 9 by 4. So minus 9 by 4, right? So how much am I going to get? Shall I write it in the next slide? So I have 1 by 4 into integral of dx divided by x plus 3 by 2 the whole square plus 5 by 2 minus 9 by 4. Plus 5 by 2 minus 9 by 4. Am I right? So 5 by 2 minus 9 by 4 is going to be 1 by 4. So multiply and divide with 2. So 10 minus 9 is 1 by 4. So 1 by 4 into integral of dx divided by x plus 3 by 2 the whole square plus 1 by 4. No, 1 by 4 means can I write it as half the whole square? Right. There is going to be half the whole square. So this will be 1 by 4 into 1 by A. A is half into tan inverse of x by A. So x plus 3 by 2 by half. So basically it will be 3x plus, sorry, 2x plus 3 divided by 1. So this 2 will cancel this 4 twice. So you're going to be left out with half of tan inverse of how much? 2x plus 3. And what is this? This is only I2. So I already have I1 there. So the final result will be this plus I2. So what is this value? 1 by 4 into log of denominator, no? So answer will be 1 by 4 into log of 2x square plus 6x plus 5 plus half of tan inverse of 2x plus 3 plus c. Clear with this? So this is going to be the final answer. Clear with this? So just make a note of it. You're done? Done with this? Okay. So the next problem also you're supposed to proceed with the same idea. Thing is, you need to find out and convert it in this format and tell me after you come to this step. Okay, do it. Thirty-four minutes. Sir. Correct. 34 minutes. 33. What is there in the book? Where minus is there? Where? 4x 5 minus 4x minus x square. It's okay. Do with this question. You should. It will change. It will change. But do with this number. Still, it will work. I'll do this and show. எங்க இருக்கு இந்த slide? So the second question is for this one. Okay. So integral of x plus 3 divided by root of 5 minus 4x plus x square. Right. So you'll write x plus 3 is equal to a into d by dx of 5 minus 4x plus x square plus b. Right. So what is this going to be? A into minus 4 plus 2x plus b is equal to x plus 3. So this will be minus 4a plus b plus 2a into x. This is equal to x plus 3, which implies 2a is equal to 1 or minus 4a plus b is equal to 3. So what is the value of a? A is half. So when you take half and substitute it, you will get minus 2. Minus will go that side as plus 2. So b is 5. So how will it get converted to? In the place of x plus 3, you can write it as integral of half of 2x minus 4 plus b, that is 5, the whole divided by square root of 5 minus 4x plus x square times dx. Is that clear? So we'll take this and solve it in the next slide. So what are we going to get? Tell me the values. Integral of half into 2x minus 4 plus 5, the whole divided by square root of x square minus 4x plus 5. Actually, it is 5 minus 4x plus x square. You reverse and write it. So dx. So you will split this term with the denominator. So half into integral of 2x minus 4 divided by square root of x square minus 4x plus 5 plus 5 into integral of dx divided by root of x square minus 4x plus 5. Right. So if you put this x square minus 4x plus 5 is equal to t, right? Then what will you have? So you will have half into integral of dt divided by root t plus 5 into integral of dx divided by, what are you going to get? Root of x. Yes, it is x minus 2 the whole square plus 5 minus 4. Why is it 5 minus 4? 5 is written minus 2 square, that is 4. Right. So 1 by 2 into, this is going to be 2 root t plus 5 into, what is the integral of dx by x square plus a square? So log of x plus, so that is x minus 2 plus this whole thing under a root. So that is going to be root of x square minus 4x plus 5, right? So 2 and 2 will get cancelled. Answer will be square root of t. How much is square root of t? It is x square minus 4x plus 5 plus 5 times log of mod x minus 2 plus root of x square minus 4x plus 5 plus c. Is the point clear? Am I clear with this? Right? So this will be the required answer. So check the answer once. It will not match, no, because your textbook problem is something else. But I hope you understood the logic. So many physics concepts. Actually, I can project and show it here. Actually, they're explaining so many things. Why don't we see? We'll see the Chandrayaan-3 landing. Okay, this can be learned later also. They're explaining so many physics concepts. Are you all done with this problem? See, concept wise, this is all you need to know. Because you'll write the same thing, no? Integral of dx by root of x square plus a square means what is the formula? Log of x plus root of x square plus a square. So x square plus a square, now when you solve it, you will get x square minus 4x plus 500. So copy it first. Those who are online, did you all copy?
Yes, sir.
Sir,
Okay. Baldra. Right. 1 minute, let me try to adjust the sound. இருக்குடா 1/6. I'm not sure. You're not able to go mute. Let's okay. Hindi lo varudra. I heard in English. You all understand Hindi, huh? Hey, they're talking in English also. Listen, listen.
We can see the scientists are analyzing the longer data.
It's a mix of both.
सभी वैज्ञानिक के जो भी डेटा
Now, how to get the sound from there?
वो डीप स्पेस नेटवर्क आईडीएसएल 32 के द्वारा प्रोवाइड किया जाता है। और अगर हम बात करें पावर डिटेक्ट के तीसरे चरण का, जो कि फाइन ब्रेकिंग फेज होगा, जिसमें लाइनर लाइनिंग साइड से जस्ट 800 मीटर वर्टिकली होगा। इस चरण को पूरा होने में लगभग 3 मिनट लगेंगे और इस चरण के पूरा
This sound is coming there.
लैंडर की वेलोसिटी लगभग शून्य हो जाएगी।
The scientists here at this track are glued to their systems, analyzing all sorts of complex data. We are very close to the power descent, to the start of the power descent phase.
Hey, I'm. यार रहा है?
चौथे और अंतिम चरण का, जो कि हम लोग नेविगेशन फेज या टर्मिनल डिसेंट फेज में कहा जाता है। इस दौरान द्वारा के हाइट और वेलोसिटी की गणना इनर्शियल नेविगेशन को भेज दिया जाएगा। इस दौरान लैंडर 150 मीटर की ऊंचाई को प्राप्त करने के बाद कुल 131 सेकंड लगाएगा। इस पड़ाव पे आने के बाद पुनः लैंडर 22 सेकंड के लिए हवरिंग करेगा।
Trying to get the sound from here.
के द्वारा जो कि लगातार लैंडर के कनेक्शन में बना हुआ है।
Gun and the lander module is propelling towards the moon's surface along the intended trajectory.
ಇದಕ್ಕೆ ಐದು ಟ್ರೆಂಡ್ ಇದೆಯಾ
During the training phase, the lander module is brought down over 680 meters per second to 350 meters per second. Altitude will be brought down from 30 kilometers to 7.4 kilometers at the end of the breaking. The duration of 690 seconds or 11.5 minutes. Currently, the latest version of the accelerometer package data is aiding in the navigation.
जी हाँ, अभी आप स्क्रीन पे देख सकते हैं कि लाइनर 191 किलोमीटर अभी तक इसकी वेलोसिटी लगभग
दोस्तों ऑनलाइन கேக்குதாடா Is there anyone online?
The lander module has traveled a distance of approximately 228 kilometers. The complete down range that will be traveled during this phase shall be nearly 713.5 kilometers.
जी हाँ, कुल 745 किलोमीटर के इस ब्रेकिंग फेज में आप देख सकते हैं कि हम लोग
முன்னாடி வாங்க கேட்கல नहीं 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 பேசிக்கிட்டே இருக்கீங்களா
कंप्लीट कर चुके हैं
We can currently see that the altitude of the lander module is nearly 30
அவன முதல்ல வெளில அனுப்பு.
को देखते हुए हम सकते हैं कि बहुत ही अच्छे तरीके से जो भी प्रोजेक्ट है उसी पे अपना आगे चलते हुए बढ़ रहा है
இதான் புரியுதா அதுல கிராஃப்லாம் கொடுக்குறாங்க அதெல்லாம் என்னது அது டிஸ்டன்ஸ் டைம் கிராஃப்லாம் படிக்கிறீங்க இதுதான் அது that is what they are using in real time
We can all see the seriousness and the concentration with which each and every parameter of the lander module is being analyzed. The performance so far seems to be nominal.
जी चूंकि एलएस एक्टिवेट किया जा चुका है ये ग्राउंड से कोई कमांडिंग नहीं की जा रही इस दौरान आपके स्क्रीन पे ये सारे डेटा जो कि डीप स्पेस नेटवर्क से रियल टाइम में आ रहे हैं इस मेथड में सेकंड और थर्ड ऑर्डर गाइडेड पॉलिनोमियल का प्रयोग हुआ है जो कि इनर्शियल थ्रस्ट और एक्सेल के हमेशा सुनिश्चित करेगा
During the entire design, there is no ground intervention and the clear has taken charge. The preparation for today's event had started nearly 48 hours before, wherein various pre-selections and uplinking of parameters were done. We can see that the vertical velocity of the lander module has been brought down. It is continuously coming down. And the ALS had already been initiated 1 hour before the scheduled time of the power descent
it has
starts.
to still travel it has a cover range to cover
The TechM was switched off and lander was submitted to the pavement.
so that's what they told us see there from the altitude of 30 kilometer it is being brought down to 7.4 kilometers in 11.5 seconds for that to happen they have to bring down the vertical velocity but horizontal velocity is still going to exist because it's going in a parabolic trajectory you're able to understand but still they have to control this no or else what will happen there will be a crash the lander will directly go and hit the velocity is higher right
Attitude.
जी हाँ आप अपने स्क्रीन पे देख सकते हैं कि लैंडर मॉड्यूल जिसकी शुरुआत में वेलोसिटी 1680 मीटर प्रति सेकंड थे लगभग 1150 मीटर प्रति सेकंड हो चुकी है जो कि एक बहुत ही मैजिक
அப்படினா approximately டா ஏய் hey are you guys online
ये भी बताते चलो कि आप
Yes, sir.
स्क्रीन पे देख सकते
can everybody respond
Yes, sir.
yes good
हैं कि लैंडर मॉड्यूल का altitude धीरे-धीरे कम होता हुआ दिख रहा है और जो भी एक्सपेक्टेड भी है अभी हम बात करें करेंट एल्टीट्यूड की जो कि 5 किलोमीटर के आसपास
आप स्क्रीन पर ये भी देख सकते हैं Chandrayaan-3 lander imager display. The lander imager is continuously taking photographs of the moon surface and that is also being streamed here. Currently, the horizontal velocity has been brought down and the distance traveled is 574 kilometers. The current altitude is 27 kilometers as can be seen on the screen.
जी हाँ करीब करीब अपने
அவன் கேட்டான் கிராவிட்டி இருக்கானே இருக்கு ஓகேடா சரி ஓகே இருக்கிறேன் it is there it is 1/6 of what is experiencing but still it is going to be a projectile motion like it's going to be a parabolic path.
The next phase after the rough braking phase is the attitude hold phase, which will be for a duration of nearly 10 seconds. The lander will be oriented such that both the altimeters will be moving exactly towards the moon's surface. At the end of this attitude hold phase, height measurement update to navigation system will be given from the laser and car band altimeters. Currently, we are in the middle of the rough braking phase.
जी हाँ अगर हम ध्यान से देखें तो लगभग 8 से 8 मिनट की यात्रा के बाद लैंडर अपनी हॉरिजॉन्टल वेलोसिटी को लगातार बढ़ते हुए ऊंचाई अभी की ऊंचाई 24 किलोमीटर की ऊंचाई प्राप्त कर चुका है के आंकड़े को देखते हुए हम कह सकते हैं कि लैंडिंग पूरी तरह से नामिनल यहाँ पर हम देख सकते हैं कि हॉरिजॉन्टल वेलोसिटी लगातार कम होती हुई दिख रही है currently 22 kilometers, which is again going to be coming down, and that is not affected.
Have joined now. We are in the power descent phase and we are in the rough braking phase, which is the first phase of the power descent. We have currently traveled a down range of 697 kilometers, and the down range that has to be traveled during this phase is 713.5 kilometers.
जी हाँ अभी आप देख सकते हैं कि लैंडर की हॉरिजॉन्टल वेलोसिटी 720 मीटर प्रति सेकंड हो गई है लगभग हम देख सकते हैं कि 9 मीटर प्रति सेकंड वेलोसिटी को कम किया जाता है At the same time, we can see the altitude of the lander is just 17.8 kilometers from the moon's surface, which is going to be around 7.4 at the end of the braking phase.
इस फेज के बाद हम जाएंगे towards the attitude hold phase, where we will be expecting sensor update from the laser and car band altimeters. We can see the visualization of the lander module moving towards the moon's surface. The current altitude is nearly 15.2 kilometers and the distance traveled is 754 kilometers. You can also see the image that the lander imager and be provided.
जी इस ब्रेकिंग फेज के दौरान 8 किलोमीटर के चारों तरफ इंजन अपने कार्य को पूरी तरह से अंजाम दे रहे हैं और लैंडर के हॉरिजॉन्टल वेलोसिटी को लगातार कम कर रहे हैं अब तक लैंडर लगभग अपने 75 से 80% की यात्रा पूरा कर चुका है
12.29 draw. It has to come to 7.4. Still,
Phase, we should be having the phase, which will continue for nearly 3 minutes. The whole phase is being driven by the autonomous landing sequencer and there is no intervention from ground.
जी हाँ अभी आप अपनी स्क्रीन पे देख सकती हैं कि जो करेंट आल्टीट्यूड है चंद्रमा की सतह से मतलब 10 किलोमीटर
అదంటే అదే
अपने
படம் பார்த்தே கெட்டு போனோம் அடுத்த ஜெயிலர் நான் என்னன்னு கேட்பான் டேய்
दक्षिणी अफ्रीका के जो
இப்போ 7.54 வந்துருச்சுடா 7.4 rough braking is over rough braking is over now altitude hold is going on புரியல trying something no now the fine braking part is going on so rough braking is over now the fine braking so rough braking over with 7.4 kilometers now it is going on
यहाँ इस दिन पे देख सकते हैं कि लैंडर ऊंचाई चंद्रमा के सतह से लगभग 3 किलोमीटर से कम हो चुकी है
We are very close to the moon surface, nearly 2.6 kilometers, as we can see.
Deus wait
जी हाँ अब हम फाइन ब्रेकिंग
இருடா ஒரு நிமிஷம்
Lot of applause indicate that till now the performance has been nominal. We are in the vertical descent phase 1. The altitude is being brought down from 800 meters and we are nearing and approaching the lunar surface.
जी आप अपनी स्क्रीन पे देख सकते हैं
being constantly reduced. And the lander module has begun its descent towards the landing site.
Yeah.
15 meters. This is now final. And the last few minutes.
Yeah.
Hey, 72 meters. You. கை தட்டுங்கடா. Nice, no? Landed. At last they made it up. Huh? Guys, those are online.
Sir.
Yeah. We'll wind up. Okay, join for the physics class.
Okay, sir.
Okay, sir.
Thank you, sir.
Yeah. ಯಾರ ಅಂದ ಆಂಟಿ ಇಂಡಿಯನ್ ಒಂದನ